Yes, MK the guy. For the hybridizing molecules containing double and triple bonds, I'm going to use example of the ethene and ethyne. But before ethene and ethyne, we are going to do ethane to see how ethene and ethyne comes in. So ethane, it is CH3, CH3. Then ethene is this with a double bond. Then in ethyne, we have triple bonds. So we are going to use these three examples to see what happens in hybridization. So carbon, we know that carbon, its atomic number is 6. So it is 2 to 4. Or you can say it is 1s2, 2s2, 2p2. At ground state, carbon is having this 1s2, then we have 2s2 and 2p2. But in 2p, we have only 2 electrons. One orbital is empty. So this is the ground state. So at excited state, remember, it is C, you're having 3. For in case of ethane, we're having 3 hydrogen atoms bonded to carbon. Then this carbon bonded to another carbon with 3 hydrogen atoms. Meaning that each carbon needs 4 electrons which are not paired, such that it can form bonds within 3 hydrogen and another carbon. But here we're having only 2 unpaired electrons in the P subshell. This is S and this is S. This is the 1s, this is 2s, this is the 2p. Then in excited state, we shall have this one will remain the 1s, we shall have this. Then 2p, 1 electron will be promoted to from S to P. We shall have 1 electron here in S now. Another electron is promoted to P orbital. So we shall have these electrons like this. So now we're having 4 unpaired electrons. So to form single bonds for ethane, form single bonds, we shall use all these 4. Mean that we shall hybridize all of them. We shall have a ground state like that. Then these electrons, they are all hybridized, form hybrids, which are having same energy, or they are form degenerate orbitals, so form hybrids. These are the sp3 hybrids. We used 1s and 3p electrons to form the hybrids. So, mean like this hybridization is for one carbon. So even this carbon having the same hybridization. So we shall have one carbon like this with these hybrids. So we shall have this, and this. So another carbon will also have same. So one electron will bond with another carbon. Shall have this. Remember, hydrogen is 1s1. Mean that we have only 1 electron for hydrogen and it is in s orbital. Mean that its shape is this. Mean that from this we shall have hydrogen atoms, or the electrons from the 1s for hydrogen. So these are hydrogen electrons. So this is ethene. This is ethene. I mean ethane. This is ethane. And we are forming single bonds. Then in case of ethene, now for ethene we are forming double bonds. We shall have this one remains at ground state. We're having this, the one is from here now. For excited, from here, excited state, now we want to form the double bonds. Now, instead of bringing all these four hybrids from here, we shall bring only two. We shall have one S, and these two form three hybrids. One of the electron remains. So, hybrids, this is P. Unhybridized P orbital or P electron. These are the sp2 hybrids. These are sp2 hybrids. This one is unhybridized. Remember, for the P shape is like this. For the hybrids, it's like this. I think, don't forget. For the S, is like this. This is S. This is hybrid. sp hybrid. This is the P. Now, if this carbon, this is its hybridization, we shall have a carbon having three hybrids. So we shall have 1, 2, 3. And you have one unhybridized electron. So we shall form this hybridized electron like this. So even this carbon will have same orientation of the electrons, like this, like this. Then this one forms a bond with this carbon. Then we have the unhybridized electron spanning through. I see. Now, this unhybridized electron will also try to form bonds. These ones, they are bonded to hydrogen atoms. So we're having hydrogen, and hydrogen. But these ones, they try to form bonds with each other. So ethene, we have a carbon. You have a carbon having a sigma bond. A sigma bond is formed by head to head. It's head to head. Head to head. So it is this electron and this electron. Then we have this bond for the pi bonds. Though it is shown like this. But for it, it's formed by sideways overlapping. So the sides of the hybrids, the unhybridized electrons, they try to overlap. And for it, it's at the upper side and the downer side. But for these ones, the sigma bond is in between. It's in between the two carbons. But this one, it's down and above. So we shall have this with hydrogen atoms. Hydrogen, and this hydrogen. That's what we have. Then for triple bonds, or for the ethyne, we shall have at ground state, we're having this. For the 1s, it's like this. Then for the hybrids, we shall use only one p electron. So we shall have 1s and 1p hybrids. Then the remaining unhybridized p electrons, they will be here. So these are the unhybridized p electrons or orbitals, unhybridized p orbitals. These are the hybridized orbitals. These are the hybrids. So we shall have a carbon having two hybrids. It is sp, one s and one p. So it is sp hybrid. They are sp hybrids. So we shall have one hybrid and another hybrid. Then also this carbon will have one hybrid and another one the other side. So it will be like this. Carbon, even this carbon, we shall have this and this. Then these two unhybridized electrons will span through. So we shall have them like this. Another one like this. Even this one we shall have this and this. So this is the sigma bond and these are the pi bonds. So they try to form bonds. And here we have hydrogen and another hydrogen using their s electrons. So that's why for ethyne it will be C with triple bonds. One is sigma bond and these two they are pi bonds with one hydrogen and another hydrogen. So these ones, this is the triple bond, double bond, single bond if we are using ethene, ethyne and ethane. Other atoms, you can try them and see how you can do them. Yes, thank you for watching. Same the guy. Please don't forget to subscribe, like the videos and share. Thanks so much.